Welcome to the project demonstration of control and operation of a DC grid based wind power generation system in microgrid. So in this version of the project we are going to do the buck boost operation for the grid applications. So means generally the buck boost operation will be done when we are charging a battery from a source which is a variable current and variable voltage. So in this version we are going to control the output voltage from the battery to the grid. So here we are using DC grid representing with these LEDs. So whenever we are driving these LEDs load from the 12 volts battery, so then the system will measure the voltage, and based on the input voltage it is going to controlling the pulsating signal to this MOSFET in order to maintain the maximum power for this load. So then we can control the power as well as means of voltage and currents. So then parallelly we are going to set the maximum output voltage to this LEDs. So here we are going to measuring the voltage from this voltage sensor which is connected A0 pin, and parallelly we are going to control the PWM signal to this MOSFET. So here the flow from the wind power, the voltage given to the battery parallelly to the microcontroller through this voltage sensor. So we can charge a battery with 230 volts AC also. So just by giving the 230 volts AC inputs to the system, then the system will charge a battery in a duration of 8 hours. So this is a charging indication from the grid power supply AC. And next there is one more light over here, right? You can see that when I am rotating that, so you can see the light on the charging indication, so which is used to charge battery through the wind power supply. So then coming to the battery ratings, so we are using 12 volts 2 amps battery. So this consists of two battery packs, each battery pack of 4 volt 3 number of batteries are connected in series. So we will get 12 volt 1 amp and 12 volt 1 amp. These two are in parallel, so we will get 12 volt 2 amps. So till now we have seen that the voltage from the battery and voltage from the transformer given to the battery. The output of the battery given to the motherboard to make it run. With the help of 705 regulator, we will provide the 5 volts power supply to our PIC16F72 microcontroller. So when we switch on the kits, this is the on-off switch. So when we switch on this, so the system start reading input from the wind power supply, and based on the wind power supply, and we are going to controlling the output power supply from the battery to the load. So this is the load on-off switch. So we are going to on-off, and this should be on, and this is the on-off switch. Okay, so when we switch on this, welcome message, and then after monitoring so the voltage. So when it rotates in anti-clockwise, so we can see the generated voltage on the LCD display. Right. Okay. So parallelly, when we switch on this, the system is ready to control the output come from this battery to the load. So then the system is keep on maintaining sufficient pulsating signal to the MOSFET to maintain the maximum power can be drive from the battery to the load. So here we are using the capacitor and a MOSFET to charging and discharging purpose, and diode to block the back current flow from the load to the battery, so that we can maintain the uninterrupted power supply to the load directly. So coming to the transformer ratings, we are using 12 volts 750 1 amp transformer, and generator ratings are 12 volts 20 watts power can be generated from this one when it's rotate continuous rotations around 1000 rotations per minute.